Alright, welcome back. It's part 2 of our lecture here. I want to talk a little bit about the whole business of weather and climate. This is such a standard thing to talk about on early in a class that's got an atmospheric science designation or anything like that. It's often the case that we want to make sure that we're clear about the definitions between weather and climate. In fact, the IPCC Fifth Assessment Report says weather describes the conditions of the atmosphere at a certain place and time with reference to meteorological parameters like temperature, pressure, humidity, wind, the presence of clouds, precipitation, and so on. I think we can understand that. Weather is you step outside and you report what you see. What are you observing? Now, that's not hard to picture. On the other hand, coming up with a definition of what you mean by climate is a much more complicated endeavor. And it turns out no single definition really encompasses everything that we need. Rather, it's useful to compare definitions. For example, I have this nice definition that comes from the American Meteorological Society, and we're going to be picking this thing apart a little bit here. It says, the American Meteorological Society says that climate is the slowly varying aspects of the atmosphere, hydrosphere, land surface system. Okay, notice that it's talking about the system. It's not just the atmosphere, but it's also the land surface, the hydrosphere. The hydrosphere, remember, is water moving through the hydrologic cycle. So oceans, ice, clouds, rain, groundwater, rivers, etc. We're going to be experiencing all of that and the potential for all that to change associated with climate change. Just to kind of kick onto this here, they said on their definition the slowly varying aspects of, okay, well, it might have been better to say not changing, except, well, we want to talk about climate change. This is kind of a stickler of a word here. We're not talking about things that are changing like from day to day or hour to hour, even season to season. We're talking about things that at best change very slowly about the atmosphere, hydrosphere, land surface system. It is typically characterized in terms of characterized. Characterized is a hard word, it's a bit of technical jargon. If you're not into the jargon, described might have been a better word. Okay, the climate is typically described in terms of suitable averages in the climate system. Averages, like average temperature, or average rainfall, or mean wind direction, or something like that, over a period of a month or more. We don't in general talk about even like short-term climate of like a day or a week. I'm not even loving this answer of a month or more, although we certainly will from time to time see June 2009 what looked like this. Okay, I'd rather talk about like summers in the 21st century, where we'd be talking about longer periods of each year and a longer number of years, but okay, we're at least talking like months. Okay, so you would say, the average temperature last month in Omaha was, and that could be a description of the climate in Omaha last month. Taking into account, as the definition says though, the variability of all these quantities. I mean, knowing that the average temperature last month in Omaha was 30 degrees Fahrenheit is useful, actionable information, but it's a whole lot better if you know like the range of the temperatures or more technical measures of the temperature variability like variance or standard deviation or something like that. That's pretty jargony of a definition. Let's go to a little bit more interesting. Every meteorology textbook then pulls out an old chestnut that Mark Twain apparently wrote 150 years ago that says, climate is what you expect, but weather is what you get. Well, okay, I understand where he's going with this, right? I mean, this isn't obviously a scientific definition, but it gives us the right intuition about these ideas. Weather is what you're seeing right now at this moment. The broad idea, I know what winters are like in Omaha. I know what winters used to be like in Omaha. What you've gotten, what you expect of the weather in a region, that is the climate. Neither of those are really great definitions. Again, just because illuminating the differences in the definitions is useful, let me just actually pull out the intro textbook, ATSEVS533 textbook, that says climate is the statistical properties of the atmosphere, including measures of average conditions, variability, and so on. I like this rather glib definition because it's very clear that climate is about statistics. It takes observations, it takes lots of observations that are in some way combined to make quantitative ways of describing it, like average or variance or standard deviation, a quantitative way of describing the climate. And in general, as kind of just a standard for such things, we will typically describe the climate of a location in terms of 30 years of data. That's just sort of the standard that we use in atmospheric sciences and so on. So, for example, if you are told that the average high temperature on this date in Omaha is 32 degrees Fahrenheit, where that information typically came from is that they took this date on 30 years and took the average of the average high temperature on those 30 years. So, for example, it probably was something like 1980 to 2009 or something like that. They typically move in decades like that. And does it have to be, but that is typically the way it's done. So you need at least 30 years. That number was not just pulled out of their head. That comes to us from statistics. If you've taken any kind of statistical theory type classes or something like that, there's a whole lot that changes in statistics once you have a sample size of 30 or more. Smaller than 30 is much more difficult to prove statistical significance, and you have to switch to students' t-tests and things like that you may have heard of. Whereas once the sample is 30 or bigger, there's large number tests that work better. So it's not random that they chose this number of 30. Switching back, though, to information about climate that's in the IPCC Assessment Report 5, they say, again, written by a committee, climate, in a narrow sense, is usually defined as the average weather, or more rigorously, as the statistical description of terms, in terms of means and variances and so on, of relevant quantities over a period of time ranging from months to thousands or even millions of years. Yes, we will even get into like paleoclimate and stuff like that, the climate of the past in this class. Everybody loves paleoclimate, it's a fun thing. So defining climate is tricky. You might even remember from classes like ATSEVS533 that there were all kinds of other strange ways to define climate in terms of like the plants that live in a particular location, or, oh gosh, I can't even remember, land use and things like that. Here we're going to be doing it more quantitatively in terms of statistics of atmospheric parameters like temperature and winds and humidity and rainfall and so on. Now, before we move on to a third part of this lecture, let's go ahead and start asking some questions. And again, I want to remind you, look off to the side of the screen here. You've got lots of ways to, right now, pause that video and ask me questions. And as long as it's during business hours or whatever, you've got all the information over there. We could be talking in a minute from now. Okay? But first, let's ask some questions. Question 3. To describe climate of southern Indiana, I would need, where I live, southern Indiana, A, a model of the global climate system, B, a thorough understanding of yesterday's weather here, C, 30 years of meteorological observations from this region, or D, measurements of the greenhouse gas concentrations here. What would I need if I wanted to just come up with a quantitative description of what is the climate of this region? All right, make a choice from those 4 options and get a little feedback before you move on to question 4.